that we have been given n petrol bunks into the city. Now this question was also from one of the interviews, okay, and it's very famous question nowadays. So what's the question? That you have been given n petrol bunks or cities or some spots that you can visit. Now they are arranged in a circle. That means this route which is given to you, they are into circle. Now you are given the fuel and the distance. So let's say at point A, you can have 5 liters of fuel. And if you reach to point B, you can have 3 liters of fuel. Okay. So this simple thing which is given to you. And you have been given the distances in between the points. So let's say as per the diagram, we have 5 points and the 5 things which is given to us, actually not 5, but 10, which is 5 distances and 5 petrols. So that has been given to you. What you need to find it out is that can you complete the circle of these 5 cities or the 5 petrol bunks? That is what you have to find it out. Let's say the answer is yes, you can complete the circle. Then what would be the starting point? This is what you need to think. Now here, when this question was asked, okay, the people were given that you can think that the persons or the car or whatever is vehicle is given to you, its average is 1 kilometer per liter for simplicity, so that the 8 kilometer distance is there that can be traveled with 8 liters of petrol. That's it. It's just for the simplicity. So now if this data is given to you, okay, think logically, not just in terms of data structure, consider it as a puzzle. How will you try to achieve this thing?
What is the capacity of the vehicle to hold the fuel?
That's maximum. So let's say maximum you can have over here 12 liters of petrol. Then maximum you can hold 12 liters of petrol, or let's say it has been given infinite. Consider that whatever the maximum need you have, that is infinite. But consider that it's something like this. Let's say you thought that I'll start from A. Okay. Yeah. Then at A, you'll have only just 5 liters of petrol. So you can go into either B direction or E direction. Now, if you are going into E direction, 5 minus 5, right? 0 liters of petrol remaining when you reach to E. Now at E, you'll have 7 liters of petrol. So in that way, you can do this. Now think about it, how you will tackle this question if this question is asked to you. What will be the brute force method? What is the average case method? Anything that comes into your mind, let's discuss. And from that discussion, we'll try that how to arrive at a proper solution, or what can we think when there is nothing working. Any guesses, anything which is coming into your mind? Consider that this question is asked to you into interview.
Hi, sir.
Yeah.
First, we will start with the C.
Okay, so you're going for the
C.
That is called greedy approach, right?
I don't know, sir. I am guessing my thought is.
Yeah, that is why, because you have maximum capacity or the maximum number of petrol you have, right?
Yes.
Yeah, so that kind of thing we'll see into the algorithm as well, that when you are targeting something like I have this maximum, so I'll target that first, or I have this minimum, let's say minimum penalty or something like that. So as it is a minimum, I'll target that thing first. So such kind of an approach is called greedy approach. Okay. So you think that greedy approach will work. Okay. So let's think from C, can we complete the circle or not? So in which direction you will go? You can go in one of the directions. So via D, right?
Yes.
That is also you are going with the not greedy approach, but any approach you are going. So 12 minus 7.
7, 5.
5 plus 1.
1, 6.
6 minus 4, 2. 2 plus 7, 9. Right? 2 petrol is remaining, 7 liter you got. So 7 plus 2, 9. 9 minus 5,
9
4.
liters.
9
4.
minus 5,
After
4. 4 plus 5, 9. 9 minus
9.
8,
1.
1. 1 plus 3, 4. 4 minus 4,
4.
0. So you can
0.
complete it. Now, do you
Yes.
think that greedy will always work?
No, sir. In some cases it will not.
Exactly. So as we have to create a perfect strategy, we need to think that every time will I write the code with a greedy? Why? Because let's consider the case in which it cannot be started with 12. Let's say
Okay, sir.
the distance is, let's say, 8 over here.
Okay.
Then we cannot, right? Because
Yes.
1
1 liter is
increased and over here it will decrease because at the end
mm.
we had 0 liter remaining,
Yes, yes.
right? So it's not necessary that if we start with the highest liter of petrol, we can complete it. That is first part. Now, if I start from A in this case, probably, I'm not sure, we can complete it. 5, 8, it's not possible. 5 minus 5, 0 plus 7. 7 minus 4, 3. 3 plus 1, 4. No, still it is not possible from A. So if we go for the brute force approach, then what is the approach or what is the complexity? Obviously, we'll start from A into one direction. We cannot complete. So from start from A in another direction, we cannot complete. So each station and 2 directions will follow. If we can complete the circle, answer is yes, we can complete from this node. If we cannot, then I'll move to next station B. Again, in the both direction, I'll go B to C wise and B to A wise. Again, from C to this wise or C to this wise. Again, from D to this wise, clockwise, anti-clockwise. E to clockwise and E to anti-clockwise. Now, in that, obviously, the time complexity is order of n square, right? So brute
Yes.
force is not a feasible solution for us right now. So what can be other way? Because over here we need to find it out first thing that can we first of all encirculate the tour. So whatever the tour is given to us, whatever the graph is given to us, anything, can we encirculate this thing or not? That is what our first question. If we can find that yes, I can complete the circle, then and only then I need to find a starting point.
High level
Yeah.
for finding out whether we can even make the tour or not, we can do one thing. We
Yes.
can add the nodes, means the value of the nodes and the petrol that we have in total. For example,
Exactly.
that is the first thing that we can do to ensure whether we can even complete the tour or not.
Exactly. So exactly that was my point. That when we were thinking, right, that can we encirculate or not, we were seeing that we have 5 liters of petrol initially, right? Let's say we are starting from A, let's say. And then we can go into only one direction, which is 5 to E. Why? Because we have only 5 kilometers of distance possible that can be covered with 5. So that means we have that 1 kilometer per liter, which is given to us as an average. So that means if I have X amount of liter of petrol, I can travel less than X kilometer, less than or equal to X kilometers, right? That means if I have 12 liters of petrol in the whole path, I can maximum travel how many kilometers? 12. That is for sure, right? Because our average is 1 kilometer per liter. So maximum 12 I can travel, not greater than that. So we first of all, we'll need to find, can we encirculate or not? That can be very easily done. That if we do the total of all the kilometers and we also do the total of all the distances, if the distance is less than the number of liter of petrol that we have, then the circular path may be possible. Maybe, obviously it will be possible, right? So see over here, how much do we have? 5 plus 3, 8 plus 12, 20 plus 8, 28 liter of petrol we have. And how many kilometers we are thinking to travel? 8 plus 4, 12. 12 plus 7, 19, right? 19 plus 9, 28. So that means we have X liter of petrol and we need to travel X kilometer only. So that's why it's feasible. So now we got the answer of the first question. Yes. In the case when we have taken that it can be 8, the distance would have been 29 instead of 28, right? So that's why we can say that I have only 28 liter of petrol and the distance that in circular I have to travel is 29 kilometer. So obviously that is not possible. So that is a simple puzzle kind of a question. And this can be solvable by this. This can be solvable by this. Now we can think that if I have been given that, you know, I have this many amount of petrol and I can complete the travel, how to find a starting point? So obviously currently we do not think that there can be any of the logic, right? Right now there is nothing coming into our mind, let's say, right? Yes, someone is pinging. Okay, Karthik, node with a maximum petrol may not also work sometime. Why? Because we have seen one of the case in which that node with a maximum petrol may not be able to give us the complete direction. If I say something like that, then it can be, let's say, it can be something like this. If I increase petrol from here to 13, let's say I kept a 12 only. Okay, consider it as a 12 only. Okay, the distance I'm increasing over here 7 to plus 3, which is 10. 3 I'm reducing over here, which is 1. Okay, and let's say so 12 minus 10, 2. 2 plus 1, 3. 3 and 4. So we clearly see that in some case it may not be possible. And if yes, then also we'll need to travel both the direction to try. Let's say if it is possible, then we need to try both the direction to try. You see that clearly in one direction, clockwise, it was not possible. But anti-clockwise, it will be possible. Why? Because 12 minus 1, 11 plus 3, 14, minus 8, plus 5, minus 5. So we still have 8, 7, and 4. So completely, again, we can complete, but in anti-clockwise. So my point was that in that case also, we have to go through this kind of pseudocode. This kind of pseudocode, which is you start from each node, right? And you travel into, currently I have written a code in which I'm just traveling into one direction. Okay. I'm traveling into one direction and I'm checking fuel, that this is remaining fuel. This is the fuel which I'll get at the station minus the next distance that I'm doing it. Right. If I'm reaching to the starting point again, that means it's a possible and this is the answer. If not, what I'm doing is I'm completing my cycle again. What I'm doing is remaining fuel I'm updating, fuel minus distance, and the circles plus plus. That means from this direction I'm not. So again, I'll start over here with the next node for this while loop. So it's just a pseudocode and not exactly working code. So my point is every time I'll have to think about the directions and I have to think about this. So I understand that this is not possible. This is not possible. So what can be the other way? So if you see, probably greedy approach may work. We have seen in one case it was working, in one case it was not working, but in greedy, we didn't know that in which direction to go. And that's why when we started thinking in greedy, if you see, I have kept over here 10 and I have kept over here 1. Then in clockwise, it was not working, but in anti-clockwise, it was working. Right. So do we have to find that in which direction the person has to go? No. We just need to find that which starting point is the answer. That can be the case, right?
Yes.
So let's think in a different way. And when you have to evaluate your theory, okay, you have to take multiple cases. As I say, you can take different examples with different number of nodes. At least take 2 to 3 and try to think that is it always possible that with maximum petrol you are completing the circle. If we try over here, we know that for this node, if we start, we are reaching because it's the highest number of node. Let's say I'm completing it and I'm removing it, let's say by 6 unit. 6 units, that means 6 liter of petrol now it will have. Or let's say 4 unit only. So it will have 8 liter of petrol. Now that 4 unit, I'm increasing in rest of 4. Like 2, like 8, like 6, and like 4. Right? So the total unit of petrol is now same and the distance is also same. Do you think it should be complete circle? Yes, we should be able to complete the circle. Now if we think that I'll start from 8, in this direction it was not possible. Let's think that now in this direction, is it possible or not? 8 minus 7, 1 plus 2, 3, 3 minus 4, not possible. 8 minus 4, 4 plus 4, 8, 8 minus 8, 0, 0 plus 6, 6. 6 minus 5, 1, 1 plus 8, 9, 9 minus 4, 5, plus 2, 7 minus 7, 0. So again, from here it's possible. But if you see, this 8 and this 8 both are having the highest number of petrol. Now, if I reduce it furthermore, instead of 8 over here 7, I have reduced it to 5. This I increased to 2, this I increased to 4, this I increased to 6, and this I increased to 9. Now, do you think that I can complete the circle from here, or can I complete the circle from here? Let's see from here, can I complete or not? 7 minus 4, 3, 3 plus 4, 7, 7 minus 8, not possible. 7 minus 7, 0 plus 2, minus 4, not possible. Right? That's why we try from here. 9 minus 5, 4, 4 plus 6, 10 minus 8. Yes, from here it seems that it is possible. 9 minus 4, 5 plus 2, 7 minus 7, 0. 0 plus 4, 4 plus minus 4, 0. So over here we will stop. Right? Over here we will stop. So in this also we understood that yes, probably with a maximum distance or the maximum liter of petrol, that greedy approach that we were thinking will work and into any of the direction. But now, how will we finalize that yes, it is working or not? Why? Because I'm asking this question is because when we had 8 over here and when we had 8 over here, the answer could have been this or answer could have been this. Right? Answer could have been this and answer could have been this. Then what is the correct answer? That is first part. And let's say from here I cannot travel. Then if I can travel from here, correct? If I cannot travel from here, but if I cannot travel from here, how will I validate that can I travel it from here or not? Because now I have 2 answers, probably 2 answers. And I can still tweak the questions in which way that if I start from here, we will not be able to reach. Let's say I increase the distance by 3 unit or even let's say 4 unit. So the final answer is 9. 4 unit I increased, so 1 unit I'll decrease from here. 7. 1 unit I'll decrease from here, or let's say keep 4 over here. And 2 units or 3 units I'll have to reduce. So 7 minus 3, 4. This is my final answer. Then you can see that previously from here to here, we were stopping it over here. Now I kept almost similar data over here. And over here also we cannot go. So it's just the few of the cases that we are thinking. And then I understand that probably from this, node I cannot start, though it has the maximum unit of petrol. The final answer is this only. So in case of such kind of ambiguity in the greedy also, how to resolve? Do we start and complete the circle in both the direction? That is first way. Brute force, okay? That is first way. And the brute force again will give us into order of n square. Why? That is a worst case complexity, but that will also give us worst case order of n square. Why?
Because we
Go
need
both directions.
See, even if we are going for the both the directions, we have over here right now answers, probable answers are 2, right? So even if I go into both the direction for both the 2, it is not order of n square. It is 2 into order of n, right?
Yeah.
So the brute force approach in worst case is order of n square in a case when you have all as same petrol. So at all petrol bunks, you have the same unit. Let's say 77777 everywhere you can get it. Then you have 7 probable answer, which is like n probable answers. So obviously you'll have to go for the n square approach. Over here it's a 2n because you have 2 nodes. Now you have n probable answers. That's why it's an n square. So in brute force, worst case, it is n square. So again, we landed into brute force approach in which we may not be able to find a correct answer. Then what to do? So for that, let's think, what do we have? And as we see that, yes, greedy will give us the answer, but not exactly which one, that we have to think. Then let's think in a little bit different way. The first greedy approach that we thought is max petrol, right? Right, max petrol. Second greedy approach, what we can think about the
minimum
greedy
petrol.
approach itself? Sorry?
minimum petrol.
That is minimum distance, yes.
Okay.
In this also we can think. That is second thing. Third thing, min difference. That is also a way. Now what is that min difference? The min difference is this. If I start from 5 and I go towards 8 direction, I'll have -3 liter of petrol. Physically, it is not possible, but think mathematically. And we'll go into that way only. I have -3 liter of petrol. So I'm thinking in this difference method, okay? You can try with the distance method also, but with min distance also, there'll be the similar kind of cases which we thought. You can try from different cases on your own, okay? So when in interview, you may try taking 2 to 3 small cases of 4 units, 4 number of nodes or 3 number of nodes, and you can try that can you encirculate or not. And we can find it out that we will end up into the same complexity of the petrol, because it's just either a distance or a petrol. They both are same for us. Why? Because we have 1 kilometer per liter average, right? So either you have petrol and you are traveling, or you are traveling and you have petrol. Currently, they both are same for us. Now, if I go for difference, this is what the data I have. 5 minus 8, 3. So that means if I go into this direction, I have -3 liter of petrol. And when I reach over here, I'll have 0. -3 plus 3, 0. Right? I have 5 liter of petrol, 0. 0 to 4, if I go, I'll have -4 liter of petrol. And when I'll fill 12 liters of petrol. So 12 minus 4, 8 liter of petrol I will have. Then 8 minus 7, 1 liter of petrol will be remaining. And when I'll go to the next station, 1, I'll have 1 plus 1, 2 liter of petrol. Now 2 minus 4, which is -2. So when I reach to this station, right, I have -2 liter of petrol. And when I reach to E, I'll have +7. So 7 minus 2, 5 liter of petrol. And 5 minus 5, 0. So if I do this, and at the end there is a remaining petrol greater than or equal to 0, that means I can encirculate the path. That is for sure. That was the theory that we have kept it over here also. Now the same thing when I was thinking, you see there is a minimum difference over here. That means in a worst case, if I'm starting from A, or if I'm starting from B, or even if I'm starting from E somewhere, if you start from A, you are landing up into -4 over here. If you start from E, probably some minimum numbers you will land over here. So my hunch is that over here I have minimum petrol. After that point, I have maximum petrol, or the more petrol possible. So if I start from that node, probably that is the right answer. Probably that is the right answer. We saw over here from C, in one of the direction it is possible. So we have currently our answer over here, C. Now, obviously we cannot say that, hey, this is the answer, right? We need to establish our theory with taking multiple examples, right? So first we'll see this example in pictorial view, and now I'm just writing out into equation. Point A, okay, what is the last petrol that at point A we have, and we are calculating with last plus fuel minus distance. So we had initially 0 liter of petrol plus 5 liters of petrol I got, minus 8 I have to travel. So at 8A point, there is a -3 liter of petrol. So in that way, if I do, at B, I will have -4 liter of petrol. The same thing which we have calculated over here, right? And at C, I have 1 plus 1. So the first time when I'm getting a positive petrol, that can be my point, or whatever is the least petrol possible. After that, if I start, then that is my answer. There are two possible solutions. Correct? Now we need to establish final answer based upon this. As I said, we will think that I have 8 liter of petrol over here, 8 liter of petrol over here, right? So 4 reduced, 1 increased, 1 I'll increased, 1 I'll increase, sorry, and 1 I'll increase over here, 6. Now let's start to, let's think that can we have the similar kind of solution over here or not? Let's see that. So 0 plus 6, 6, 6 minus 8 minus 2, right? Minus 2 plus 4 minus 2, right? Minus 2 plus 4 again minus, sorry, minus 2 plus 4, sorry.
2, sir.
Yeah, I'm getting a little bit confused. Just a minute. Erase everything on the slide. Okay, so now we have 6 liter of petrol, we have 4 liter of petrol, we have 8 liter of petrol, we have 2, and we have 8. Okay, so 6 minus 8 minus 2, minus 2 plus 4, 2 liter of petrol we have, 6 minus 8 minus 2, 2 liter of petrol we have, 2 minus 4 minus 2 liter, 2 minus 4 minus 2 plus 8, 4 liter of petrol, 4 minus 7 minus 3, minus 3 plus 2 minus 1 liter I have, minus 1 minus 4 minus 5, minus 5 plus 8, 5 liter of petrol I have, 5 minus 5, 0. So at the end, when I'm reaching, at the end we have 0 liter of petrol remaining. Now if you see, the minimum was what? Minimum was -2. Now if you think, can I start from here? I can reach to the answer. That was our 2 cases, right? Both of the cases. So let's see. If I start from here, if I have 4 liter of petrol, 4 minus 4, 0, 0 plus 8, 8, 8 minus 7, 8 minus 7, 1, 1 plus 2, 3, 3, 2, 4. No, it's not possible. So that means out of our 2 cases, 1 case is not possible. Right? And also over here, we have 2 liters of petrol. Over here, we have remaining 4 liters of petrol. And over here, we have remaining 5 liters of petrol. Now, in this case, the maximum liter of petrol I have is over here, which is remaining maximum I have over here. So previously we were thinking remaining minimum I have over here. So from next I can start. So we had two possible answer. First positive and after the minimum. In both the cases it is not the answer. So let's think, if I have the maximum petrol remaining, from that can I start? Because it's also greedy. Probably yes. 5 minus 5, 0. 0 plus 6, 6. 6 minus 8, I cannot go. So 5 minus 4, 1. 1 plus 2, 3. 3 minus 7. In this case also I cannot reach over here. So if I start from 8 only over here, I can reach 8 minus 7, 1 plus 2, 3. No, 8 minus 4, 4 plus 4, 8 minus 8, 0 plus 6. 6 minus 5. 1 plus 8, 9 minus 4, 5 plus 2, 7 minus 2. Yes. So in this case also, I am able to complete it from here. So then we understood that there is no exact solution for this, but with the different cases we have seen. But the probable answer is either of these two, either of these two. And then we understand that in any way, if we go, our final answer is with the greedy approach. And then we say that, yes, we'll have to go into order of n square in brute force case only. So our final solution lies with order of n square. Because we have over here two cases in which the greedy, that means the maximum petrol is at two cases. And as I said, there can be a case in which all the petrol bunks have same number of petrol. So obviously you'll have to think about writing such code in which we first mark the petrol with the maximum capacity, and then we think about it. So over here you may think that, hey, we tried everything and finally we are coming at the solution from where we started, right? We tried this solution, we tried this solution, we tried this solution, we tried this solution, and we are coming out finally at the point where we started. But if you see, we understood that what can be the possible solutions, what can be all possible solutions, and what can all be wrong. So we need to finalize the approach with taking different examples and different strategy, and then only then we can say that, hey, yes, this is the final answer. See, if we sort it, so Karthik suggests that if we sort it, can we get the point? See, sorting will increase the complexity, order of n log n, that is fine. But if you see, then we will not have the exact order in which the petrol and the distance are. Let's say if I'm sorting only one with a minimum petrol, something like that, then also what I'm achieving, let's say I'm solving it something like this: minimum petrol over here is, or the maximum petrol over here is 12, then 7, then 5, then 3 and 1, and accordingly 12. I have 7 distance. Accordingly distance also I'm sorting as an object, okay? And for the 7 liter of petrol, 5 distance, and 5 has 8 distance, 3 has 4 distance, and 1 has 4 distance. Finally, it will be the same. It's just the different order that you are trying to solve. But finally, we'll have the same amount of petrol and same unit of distances. It doesn't give us anything into addition or something which can be the solution. Such kind of that data it doesn't give us, right? It's just a, if you think, it's just a random order. This is also a random order of petrol, and this is also a random order of petrol for us. So that's why we cannot say that sorting will work for sure. Obviously, we have seen that the greedy also was not working, right? So in this way, we understood that this can be our final strategy, and this can be the probable solution. So with taking this different kind of an example, we need to establish a theory or our algorithm, and then finally we can say that, hey, this is the final answer, and we can write the code like that. So you guys can try writing the code for that. Okay, and if you see this question into Geeks for Geeks or Lead Code, they have an order of n solution, and that too in which way? That too in this way, that wherever you reach to the minimum petrol, let's say over here we are reaching to -2, then the next node which is starting is the answer. They have said it perfectly. But if you see, if you take different examples as we have taken, we understand that that cannot be always the case. They have also taken 1 or 2 cases, and from that they have taken the probable solution that, hey, this is the answer. And we take different set of questions, so different set of data, and we solve that. It cannot be solved in order of n. So my point is, when in an interview such kind of a thing happen, instead of taking 1 or 2 examples, always think about at least 2 to 3 such set of data, and then evaluate your logic. And then finally we can say that, hey, this is the answer. This is the answer.